Everybody says Pythagoras is easy until I ask you to tell me the length of one of the sides when you know the hypotenuse, and then half the class tells it to me wrong, even in an honors class. So I have to be careful with it. Where is the hypotenuse?
Across the 90-degree angle.
Across from the 90-degree angle. Every kid says it's the longest side. No. Because a hypotenuse only exists in a 90-degree triangle, and it is always across from the 90-degree. That is the hypotenuse. Now, my grade 7 teacher said to remember it as the hippopotamus. So when we got to the test and I called the hypotenuse the hippopotamus, Mr. Bailey marked it wrong. I was a little miffed. But usually I take way longer to tell that story, but we're under a bit of a time constraint. So that you get the short version. The hypotenuse is right there, and the hypotenuse is always opposite. Now, when we use the word opposite in geometry, we mean
Parallel.
No. Across the shape. Opposite means across. If you were standing at this corner, you would hit the opposite side when you walked away from the corner. Opposite the 90-degree. The legs are the other sides. Now, you have all been taught this for Pythagoras. All of you. Which makes me want to take my pen and stab it in my eye. Because if I do this, if I draw this triangle, and call this side I call this side C, and I say that's 10 and that's 12, all of you punch these numbers into here, hit equals, and tell me this side is longer than 12. You do it all the time. You will do it on the upcoming test. Some of you will tell me that the hypotenuse is not the longest side. It's coming. I know this. I've been marking your tests for 23 years. Every year, kids do this. I hate a squared, b squared, c squared. Because as soon as I change the letters, people do it wrong. I like to do this. L1, leg 1, squared, plus leg 2 squared equals hypotenuse squared. The other thing you will all forget to do, not all of you, but on a regular basis, you will forget to square root at the end. And you will tell me that the lake that is 4 kilometers wide and 3 kilometers long is 25 kilometers diagonally. You will do this. And then I will mock you. Okay? I may even put it on TikTok. Well, I would never put it on TikTok because then I'm cyberbullying you, and that makes me the worst person in the world. Worse than actually bullying you. All right. All of you should be able to do these two in your sleep. You should be able to do them almost in your head. What is this value? Eight squared plus 15 squared. The square root of that equals what?
289.
There you go. 17. How is this one different? Raj, you subtract. X squared equals 12 squared minus 8 squared, which would be 144 minus 64, which would be 80. Square root of 80. Now, in math class up until this year, you would have put that as a decimal. Yes, it would have been almost 9. Yeah, like 8.9, right? That's fine. This year you learned that we want this to be 4 root 4 root 5, right? That's what we wanted back in our radical unit. But trig is for real life measuring, right? You can't say to somebody when you're building a building, say, oh yeah, you got to make that beam 4 root 5 meters long, right? So we're back to getting the decimals. Now listen to me and listen to me closely. I am going to say this once. Decimals, round them to the nearest tenth. Don't make me do a lesson on rounding with the best and brightest math class in the school. So when your calculator says 28.574, what's the answer? 28.6. Clear? Good. You're not going to do any work with this one. You're simply going to tell me, is it possible right now to tell me the value of x? Talk to your neighbor. You have 30 seconds. Go. Don't tell me the value. Just tell me if it's possible. Meh. Yes or no? Who says yes? Hands up. Okay, how would you do it? That many hands went up. Somebody must have a strategy. How would you do it? Tamana? You find the height of... Okay, I'm going to put some colors on here because it's confusing. I'm going to put pink, blue, green, brown, and what am I missing? Orange. Now talk. You would use the theorem to find what? The green line. What theorem? Okay. So what would be the legs you would use to find that? You would use the brown and the orange? So you would go the square root of 35 squared minus, 20 squared would equal the green line. Right? Who agrees with her? Be proud. Okay. Who has another strategy that they would have tried? Or is that what everybody would have done? Everybody would have done that? Lily. So Lily says she would have drawn, let's choose another color here. What haven't I used? This blue. You would cut that, which would make this what? So you would make, so that would make this 17.5. Okay. Anybody else have an idea? Jordy.
Well, I think it's similar to what everyone else said, but like I would just the height of the.
Use colors, Jordy.
The color.
The light blue height.
Yeah, light blue.
Yep.
You would use 10 centimeters to replace light blue.
Okay. Now Jordy says that'll be 10 because that's 10. Right. Okay.
Yeah.
Then what?
The left side of the blue line, that right triangle.
Mm-hmm.
So first off, I have a question. Do we know that the base of the orange on the blue side, the blue right side,
Mm-hmm.
is 17?
No, of course you don't.
We don't. So then you would do.
So I'm going to stop you right now. Because you don't know that, if you draw this, you cannot know that as 10. Because you do not know that as 90 degrees. The real answer to this question is, of course, you cannot do it with this information, because the information that Tamana used said that's 90 degrees. Is it? What makes it 90 degrees? It would need that. All right? That's the very first lesson you need to learn about doing trig. You don't get to make assumptions. You have to prove it. Now, what if I put this here and this here? Now could you do it? Yeah, because of course that's 20. Because that's 20, right? Or if I did this and I said those were the same, then these are split in half, yes? Then you could do it. Because if that's 90, that's 90. Everybody understand? You don't get to make assumptions. Look at the second one. Could you do it right now?
Yes.
Okay, let's put some colors on there. Take 30 seconds while I color it. Now remember, that's enough. Could you do it right now? What would you do? You would find the blue side? Doing what? Okay, so you would do hypotenuse to find the blue side, or Pythagoras to find the blue side, right? Okay, then what? So this blue side right now, we know is the square root of 10 squared plus 20 squared, right? Now what do? You can use that as a leg here. You would use Pythagoras on the blue, orange, yellow. Why not? You still don't know it's a right triangle, right? Everybody understand? No assumptions. Now let me ask you this. This is the third side of things. C, don't write this down. Is that a right angle triangle? Yes, of course it is. Why? Because 6 squared plus 8 squared is 10 squared. Does that prove this even though I don't draw it? Yes. Does everybody understand? You don't get to say something is 90 degrees because it looks 90 degrees. All right? There's lots of ways to prove it, but you have to be able to prove it. Everybody with me? Picking up what I'm putting down? All right. I am not... Oh, wait. We are going to do this page. It'll take a couple of seconds. Now, there are some rules about labeling shapes. Angles, vertices. Vertices is the plural of vertex. The vertex of an angle is its corner. Angles are labeled, in the past, this angle back in like grade 3, you would have labeled that as angle CAB. Point, point, point. The vertex lives in the middle. You could have also labeled it BAC, right? In the 10th grade, we use just the corner. Everybody cool? Everybody's good, right? Okay. Sides are labeled by their opposite. What does opposite mean? Opposite angle. So if this is angle A, what is this side? Side A. And we use uppercase for angles So we use lowercase for sides. This is little a. So what does that make this side? Lil c. What does that make this side? Lil b. What does that make this side? Lil f. What does that make this side? Lil d. What does that make this side? Lil e. All right? Now listen to me carefully. I used to have a girlfriend named Lilith, and I called her Lil if. Well, before she was my girlfriend, and I just liked her because, guys, you know, the best way to get a girl to like you is to bug her, right? Throw rocks at her, stuff like that. It's a good move, right? I know this because I watch you still do it to this day. Girls, we grow out of it. We stop bugging you and throwing rocks at you when we like you, but it takes... When I was a kid, it took till we were about 22, 23 to figure it out. But we also moved out of the house at 18. So since you guys all lived with your parents till you're 30, that means it's going to take 12 extra years, so your peers aren't going to figure it out till they're about 34. So expect rocks to be thrown at you, expect them to bug you, expect them to do stuff like that till they're about 34. But then they'll get sorted out. Where was I? Oh, yes. We label triangles by the corners. So this top one is triangle. If I label it ABC, right? I went from the small angle to a big angle to a small angle. Oh, sorry. I went the other way around. I went A, B, C. So what then is the name of this bottom triangle? If I tell you they are similar triangles, how would we name the bottom one? FED. We follow the same order. Everybody cool? Now, normally I do a whole big thing with this, but I'm not going to do that right now. When triangles are similar, they have all the same angles. And, you already know this, this is why trig works. When you compare the sides, if you compare corresponding sides, you make a ratio, yes? Yeah. So I'm going to put a yellow or a red line. No, I lie. Yeah, I'm going to put a red line up here. What is the corresponding side on the bottom triangle? Side D. Now, if I take C and I divide it by D, I will get a decimal. Everybody cool? That decimal will be the same as if I did A divided by F or C divided by, not C, B divided by E. Always. That's how triangles work. So if C is 10 and D is 15, everybody with me? And A is 5, what is F? He waited patiently for the crickets to stop making noise. Huh? 7.5 is the first guess I have. Do we have any others? Riley? We have a 3.3. Do we have any others? We have an 11.1. All right. Well, I didn't think that was going to be the way that went, but I just told you that if you compare corresponding sides, C compares to D is 10 over 15, right? Yeah. Then it's the same decimal if I compare 5 over F. So what symbol goes right there? No. It's the same. Right. Equals. How do you solve that? Cross multiply. 5 times 15 is 75. Divided by 10 is 7.5. Nice job, Connor. Yeah. All right. We get to skip page 247. I'm going to trust. It's dangerous, but I'm going to trust you on page 248. But 249 is something I want done. But not right now. Because it's only Pythagoras. What I want now is to flip to page 250. Now, before we go on, there is something, this is the most painful part of teaching trigonometry. Everybody pick up their calculator. Everybody pick up their calculator. Push clear. There is your calculator screen. Almost all of you will have a gray bar with a 0. Right? Now, everybody look on the gray bar that is your display and see if you see a letter D or D, E, G. If your calculator shows a D or a DEG, I want you to sit still and do nothing. Is that clear? You don't need to tell me. You just need to do what Raj did, drop your calculator and chill. If your calculator does not have a D or a DEG, you must look for this button, DRG, as a button. It might have an arrow by it. Push that button until your calculator says D or DEG. If that happens, put your calculator down. If you have one of the super fancy calculators like mine, like this, you must push mode. Then use the arrow keys, pretend you're playing 8-bit Nintendo, and go down until the word degree is flashing. Then you push enter. Have I covered everyone? Has everybody put down their calculator now? Here we go. Like I said, it's my favorite part. All right, now I'm going to assume everybody has it done. Now, we are going to do a test to make sure everybody has it done. On your calculator, find the button that says tan. For most of you, you will be able to push, if you push that button and your screen shows the word tan with a bracket, put your calculator down. Is there anybody still holding on to their calculator? Everybody's... Yours does not write the word tan?
It does, not the bracket. You said it was the bracket.
It's my fault, I know. I'm just having a cleansing breath. Because as you well know, my favorite thing is lawyer balling. I will change my wording. If your calculator writes the word tan, put it down. Is there anybody still holding on to their calculator? Excellent. So all you do for all of trig is punch in what you see. Now I want every single one of you to hit the button tan, then the button 3, then the button 5, then the equals button. And tell me what you... Don't say it out loud. Did you get this?
Yes.
Is there anybody in the room, except Squinty McSquintface back there?
I need a new prescription, okay? Stop bullying me.
I love how you people think that's bullying. 0.700 blah, 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 blah. Everybody got that? Oh, thank the Lord. It's the first time ever. Whew. Now I want you to do that twice more. What is the tan of 15? To 3 decimal places. This is where I check if you can round. 267 is what you're going with? 268 is what you're going with? Good. 0.268. What is the tan of 45? 1. All right. Excellent. Now, over here, draw this triangle. That's a 90 degree. Okay? This is angle A. All right? What is this as a fraction? That would be 7 over 10, yes? What would this be as a fraction? 268 over 1,000. This would be any number over the same number, yes? Okay. This decimal is actually a fraction, right? And a fraction is actually a ratio, okay? The tangent ratio is the opposite divided by the adjacent side. Now, you will notice, if you've done trig, and if you haven't, you'll want to pay attention, this is A. What does opposite mean? Across. So, what number would go there if A was 35? No. No, what number would go there? If angle A is 35 degrees, tangent is opposite over adjacent. Here I am at opposite. What number would I write there? 7. What number would I write there? 10. Why did I not write 10 here? Because that's the hypotenuse. Tangent compares the legs. Everybody cool? Now, in green, if this was 15, what would go here? $268. What would go here? 1,000. Everybody understand? Now please notice, as the angles get bigger, what happens to the fraction? It gets bigger, right? Everybody cool? Okay. Now, your calculator knows what these decimals are going to be. How does it know that? Because the length of the sides does not matter. The angle is all that matters. If I take this black line and I draw it all the way over to that wall, and I draw the hypotenuse, the vertical line all the way over to that wall, does that change this angle? No. So your calculator does this based on basically a 1, 1, √2 triangle. All right? So your calculator always knows what the values are. Here's a mistake you guys make. This 700 is not a measurement of anything. It is the decimal after you do the division of these two numbers. Everybody cool? All right. So your calculator, because it knows all the decimals, it can also reverse and do all the angles. So this question, if I were to draw the triangle, there's A. What would I write right here? What number would go there? 75. What number would go there? 100. Right? Could I put 3 there and 4 there? Yes. Could I put 5 there and 20 there? Yes. Oh, good. You guys are on a roll. Now, you will notice that I have the decimal this time. Do I know how big the angle is? No, but my calculator does by hitting the shift or second function button. Then tan, then 0.75, then equals. How big is this angle? So 37 degrees. We usually round our angles off to the nearest degree because angles, believe it or not, are counted like time. They're not decimals. 1 degree has 60 minutes in it and 60 seconds in each minute. I know it's weird. So that's why we just round our angles off. Now, what happens here? This seems to make no sense, yes? Punch that into your calculator and tell me what you get. Negative 51 degrees. That makes no sense, yes? Don't worry, we're going to do a whole bunch of work on how that works. All right? That is exactly what you do, Riley May. The triangle moves around. That would be 51 degrees, and that would have 123 over 1,000. If I move the triangle down here, that 123 becomes negative 123. Picking up what I'm putting down? Good. And lastly, what is C? 68 degrees. Good. Now, for any, please underline, highlight, Mrs. Bad Crumble Cloud around any. Specific means acute. This doesn't work for the 90. The any acute angle, the tangent ratio compares the opposite side to the adjacent side. And we remember, never the hypotenuse. It only deals with legs. Everybody cool? So here we have a triangle. I want the tangent ratio of angle A. So will you tell me a decimal? No, I want the ratio. What is it? Tan A equals opposite over adjacent. 12/5. You can't simplify that. 12/5 is as simple as it gets. No. What is tan B? 5/12. Now, tell me the value of angle A and angle B. What's the value of angle A? Raj. 67. What's the value of angle B? 23. Once you know one of them, do you automatically know the other? Why? Angles in a triangle have to add up to 180, right? That's 90 of them. If you know that's 67, you know that's 23. If you know that's 23, you know that's 67. Now, listen, please. This is the way I do this. So I'm going to write down what I type in. I want you to write what you type in. When I am faced with this, I push shift, tan, bracket, because my calculator doesn't put a bracket, or does. Bracket, 12 divided by 5, close brackets, equals. That's what I punch in. Some of you may do something different. You could do 12 divided by 5, shift, tan, shift, answer. There's a lot of ways you could do it. I don't care what you do, but I want you to write down what you push there, because you're going to do it about 1,000 times. And one of the things that bothers math teachers the most is when you people do a question, the next question is exactly the same thing, and you're like, oh no, do now. Everybody cool? All right. Turn the page over. On page 251 at the top, draw this symbol. It's a circle with a horizontal line. Go for Myers. Yeah. Yeah, she did. She had to. Is it shot? Okay. Okay. Hatch it. Hatch it. I'll put it on the back wheel. When I get home, I'll put it on the back wheel. And you don't want to drive that much in the snow anyway, because it's all season, but these snow tires. I mean, even though the vehicle's got traction assist and all of that, I'll go down there and order something like decent used for that. Yeah. Well, it's only going to last me. I get home, put it on, drive the pig apart, get a couple of used back tires, and I'll drive it in here. And we'll install it. No. Okay, thanks, Adam. Okay, bye. Okay. So, you've all drawn this symbol, yes? This symbol is what is called theta. It is a Greek letter, and we use it to describe an angle. Okay? Any angle with which we are going to work is called theta. Okay? So we know that the tan of theta, which is any angle we would work with, except which one? The 90. Tan of theta is always opposite over adjacent. And theta is the angle we care about. Okay? Now, this is the way to do trig. I know all of you have done trig already, but always do this, then you can never, ever do it wrong. Look at your triangle. Do you have a theta that you care about? Is there an angle we are concerned with in that first triangle? Yes. Theta equals x. Once you have decided on your theta, that is where you are looking at the triangle from. There I am before I went gray. Everybody understand? That means I am in charge of this triangle, so I decide where my opposites and adjacents are. What is opposite to me? 23. What is adjacent to me? 15. Then I look, okay, tan theta equals 23 over 15. Now, this is going to give me a decimal, isn't it? I want the angle. So is this a shift tan or a tan situation? Shift tan. Shift tan theta equals. And then you do that on your calculator. However you just did it. You just wrote down what you punched in. So everybody tell me the value of theta. 57 is exactly right. Everybody cool? All right, let's go to the next one. Do I have a theta? Do I have an angle that I care about? No, thetas are only angles, Selena. Do I have an angle that I care about? Yeah. What's the angle that I care about? No, x isn't an angle. I'm trying to find x. Jordy.
Well, isn't it the angle adjacent to 90 degrees?
The angle adjacent to 90 degrees? Raj, 15 is my theta. Because that's the angle which I have to work with. Because I know that one. Now, once I set that as theta, where do I go? Now I'm there. What is opposite to me? No. Opposite means what, Harry? Across. What is opposite to me? X. What is adjacent to me? 37. Tan theta is opposite over adjacent. Theta equals 15. So what do I write here? Tan of 15. Theta is 15. Equals. What is opposite? What do I write here? What is adjacent? Now, I need to do algebra because what is your job whenever you see an x? Isolate it. How do you get rid of divided by 37? Cancel. So what goes here? 37. How do you enter that into your calculator? 37 tan 15. Most of your calculators will do it automatically. Some of your calculators, you may have to push times there. Try it. See which calculator you have. So the answer is 10 degrees. We round degrees to the nearest degree. Everybody cool? All right. Let's look at the third one. Is there an angle I care about? What is it? 70, which means I now Now, what is my opposite?
14.
What is my adjacent? Tan of theta is opposite over adjacent. So what do I write here?
Tan 70.
Ooh, barf. X is on the bottom. Now, we could take a long time to show why algebraically what we need to do here, or we can be smart. Here, when the number was on the bottom, we multiplied. What are we going to hear? Divide. X is going to equal 14 over tan 70. What is X? Thank you. It's not a degree, it's 5.1. Remember, 1 decimal place for lengths. That's what I want to see. 5.09 becomes 5.1. Don't make me do a rounding lesson. So now, figure that one out. Do I have a theta? What is it? So where do I go? What do I have? Opposite is 24? What does opposite mean? Opposite is X. Can I do some work with that? Now, we're going to do something weird here, ladies and gentlemen. You all know to write tan 30 equals X over 24, yes? And you all know that X equals 24 tan 30, yes? Now, what do you want to do right now? You want to do 24 times tan 30. Don't do it. That's what you want to do, right? That's going to give you a number, isn't it? And that number is going to have a whole bunch of decimals after it, yes? Okay. Right now, I want you to do that. Tell me, what does X equal? 13.9. Is it really 13.9? No, it's 13 point blah, yes? Okay. Now, what do you want to do with this number and this empty space that I just highlighted? You want to write 13.9 there, don't you? Be honest. Is it 13.9? No. Because it's really 13.9 blah, yes? So here is what you need to do if you are planning on going forward in math. You don't round in the middle of a question. This value is actually 24 tan 30, isn't it? So here, now I told you I wanted a value for 13, or for X, so you gave it to me. But if you didn't need that value, the best way to do this is to put 24 tan 30 there. Now, isn't that a leg and a leg? And this is a 90-degree triangle, isn't it? So isn't 24 squared plus 24 tan 30 squared square root equals y? This is what you should do, because it gives you the best answer. If you round off to 13.9 and then use it, you're going to get a serviceable answer, but it isn't the best answer. Does everybody understand? If you watch a movie or a TV show that does math, like every whiteboard on the Big Bang Theory, or A Beautiful Mind or Good Will Hunting or one of those type of movies, and you see the blackboards in the classroom or the whiteboards in the classroom, this is what you will see. Because they don't want a number until they want a number. Does everybody pick up what I'm putting down? If I round this off to 13.9 and put 13.9 there, and I am trying to build, for example, a pipeline across a 3-kilometer stretch of land, and I have rounded this off to the nearest millimeter, no problem if the pipeline's only going from meterage, right? It's a millimeter off. No problem. But what if it's going 3,000 meters? If it's off for a millimeter for every meter, then I'm going to be off by 3,000 millimeters, aren't I? And my pipeline is going to be 3 meters off to the side. Not a big deal even then. What if I'm going for 20 kilometers? Like the tunnel under the English Channel. Do you think they rounded it off to the nearest decimal? No, or they wouldn't have met in the middle. Or if I'm sending something, for example, to the moon, I need a flight path. Is it okay to be a millimeter off? No, because if you're a millimeter off in 1 meter, how far are you going to be off at 37,000 meters? 37 million meters, thank you. Right? Everybody with me? Now, what I have just said for some kids is a little scary because they don't like this as a value. They need that 13.9. Do you think it matters right now? No. Go ahead and put the 13.9. But I'm warning you, the further you go, the less and less numbers you're going to have in your math work. Everybody cool? All right.
What is the answer for that? For
What's
24 squared plus 24 squared? What is the answer?
How would you do that? You would put 24 tan 30 in brackets and then use the x squared button. It would be somewhere around 175 because 196 because 13.9 squared would be around 196. If you really want to check it, see if you can punch that into your calculator. What do we get? Then you square root that. Oh, you didn't add that in yet? Okay. Well, then add that in. And the answer is square root 27.7. Everybody cool? Now, if you use 13.9, you get something very close to that, and that's cool. That's fine. I'm just in the business of showing you where you're going, right? This is not a new skill, right? Because this is 13.9. Everybody cool? I just don't like to go to my calculator more than I need to. Because every time you go to your calculator, there's a chance to push the wrong button. And who do you people believe? You believe your calculator. Even if you push the wrong button, you write down answers that make no sense because your calculator said so. Okay? So that's why I like to use my calculator as little as possible. Yeah? Yeah. And find the missing values. We've already found the missing values. Oh, that's for the next question. That should be on the next page. We're not going to use a calculator. I just want you to set it up. What's this one going to look like? Which means I'm right here. And that's where we're going to stop because I trust you can all punch stuff into your calculator. Okay? Do that for the next two. No, these should be in different order. This one should be over here. Do this one first. And after you've done the one on the right, try the one in the middle and try to set it up without touching your calculator. Check if you did the one on the right correctly. And then we'll go to the middle one. Is everybody good? Yeah? Yeah? Okay. Okay. Guys, here, book for a sec, sheet 2, please. Okay. Page 253 is a big blank page. Cut it in half widthwise. So draw a line horizontally through the middle. Draw an eye. If there's nothing to look at, that eye, its line of sight, is considered to be horizontal. Everybody cool? Everybody understand? Okay. This is the line of sight. Because there's nothing to look at. All right? Now you hear a helicopter. What do? Every single one of you looks up. Even when you're an old man, you look up. When we play rugby and a plane flies low over the field, we also, plane, helicopter. Right? You all do it. So, where would my line of sight go? Up to the plane. There's the plane, yes?
Oh, wow.
Do you know what it is? Then it's a good drawing. My line of sight will move up to the plane, yes? What did that just make? An angle. There is a theta. That theta is called the angle of elevation, or inclination. Everybody cool? The plane flies away. Plane really flew away. The plane flies away. Right? Where does my eye return? Back to my flat line of sight. Then I see a $5 bill on the ground. Where does my eye go? Down to the $5 bill. Creating what? Another angle. That is the angle of depression or declination. Everybody cool? Now, here is the problem. The plane has flown back. Now it's disappeared. It's in the Bermuda Triangle. It's in the Bermuda trigonometry. Oh, wow, is my computer not working well? Can't tap anything. There we go. The plane is gone. Yeah, literally, the plane's gone. Anyway, so the plane is back. It's a bigger plane now. Now, listen to me. On the plane is a wing walker. That guy, now when you're on the ground and you see a plane fly over, what do? Oh, plane. If you're walking on the wing of a plane, you see a guy on the ground, what do? Oh, guy. Right? Now, here's where the mistake happens. No, he doesn't fall off. This guy's eyes are looking this way, yes? But he now sees this guy on the ground, right? Creating an angle right here, yes? Would that angle be a pink theta angle of elevation or a blue theta angle of depression? That would be a blue theta angle of depression. But in this case, blue theta equals pink theta. As I look up, he looks down. These two angles are the same. Everybody cool? Meanwhile, by the $5 bill is an ant. The ant says, "Oh, guy," and looks up into my eyes. What would go here? Angle of elevation, which would be a pink theta. And it would be exactly the same as my angle of depression down to the $5 bill. Is everybody cool? Speaking of $5 bills, there is a movement afoot in Canada to get us a new $5 bill. Because Wilfrid Laurier is a rich old white person and people are tired of all of our history on our bills being rich old white men. That's why Viola Desmond is on the 10 now. Because she is the complete opposite of a rich old white man. Anyways, the movement afoot is to make it Terry Fox, which I think is pretty wicked. But of course, as you all know, bills have two sides. There's the person on one side and some kind of event or something on the other side, right? My vote is that cool-ass snowman from Carnival. Bonhomme. I want Bonhomme on the back of the 5. Actually, I want Bonhomme on the front of the 5. But he's not a real person, so they're never going to do it. But I'm starting a letter writing campaign, well, an email campaign, to put bonhomme on the back of the $5 bill. That's my hope. It won't be, but I'm hoping for it. I'm going to be wicked. I'm going to be wickeder if he was on the front, but he won't be. So, because he's not real. I've been to the Quebec Carnival. He shook my hand. All right. Is everybody cool? All right. Tonight, those of you who already did it, make sure your review is done and pretty. Everybody else, and the people that didn't do the review yesterday because they didn't watch the video, you all have one page of Pythagoras to do, the page I asked you to do. I can't remember what number it is. And page 254. So you are working on 247 and 254 and your measurement review. Whatever. This one. 249. Oh! What test?
I'm going to take that as a yes.
On measurement? Well, we're marking the review tomorrow, so when's the test? Could be. More likely Friday.